Hi, this is David Vye. I'm the Technical Director of Marketing with AWR Group from National Instruments, and I'm here with our good friend Dominic FitzPatrick.
Good afternoon.
From PoweRFul Microwave.
Correct, yep.
And Dominic, you do a lot of work with us at our design forums, and maybe we'll start, maybe tell us a little bit about your company and your consulting business.
Okay. I started the consulting business while I was finishing a PhD at Cardiff University, and basically trying to help out people in the industry who didn't have amplifier expertise within their companies, but saw the amplifier as an essential part of the products they were producing. So I used the experience that I've got, which is over 30 years now, and my skills with Microwave Office, which I've used ever since the start of the company, to develop specific power amplifier designs for people.
Okay, so what kind of technologies are your amplifiers basically?
Pretty much all discrete, but I use LDMOS and GaN principally for the power amplifiers, and we work at frequency ranges from about 81 megahertz is the lowest frequency I've done with kilowatt power levels, and strangely enough they call me a power supply designer when I do that, because they use that for driving CO2 lasers.
Wow.
And so they use these very high power RF amplifiers to create the laser power. And then I've gone up to, I've gone up to 40 gigahertz with MMICs, but most of my work now is using discrete components, so up to about 12 gigahertz.
So it sounds like a lot of custom design work.
Yeah.
You know, not standard stuff, very...
I very much do the development models that other people will then take into production. So some of the VHF base station PAs that I've designed have gone into the sort of 5K a year volumes, but I don't have to worry about doing that. I just do the basic design.
Basic design, and then they take it over from that.
But I very much make the prototypes as well and test prototypes. We don't deliver a paper design. It's a fully functioning amplifier.
Okay, and you work closely with the team to then productize it and do all that. And
that's right.
Okay, so 30 years, you've probably seen a lot of evolution in power capabilities, and
one of the funniest things is the power transistors. I remember breaking into a sweat, blowing up a 5-watt S-band radar transistor, because that was 250 pounds down the drain. Now that transistor goes for pennies, so the prices. Now I can blow up kilowatt transistors and it only costs, a couple $100. So.
Fantastic. Are there some particular vendors that you like to use mostly?
I work a lot with Wolfspeed, mainly because they've got some really good models that work well within the load pull system in Microwave Office. So again, load pull is something that I actually went to Cardiff University to really get a better handle on that, and especially their work in waveform engineering. And then now I've got that capability within the software on my desktop, which is great. To really analyze the effect of impedance on power amplifier or power transistor performance. So I really enjoy doing that.
Well, one of the things that's been really nice is that you've taken that knowledge, you've done the design, and then you've been very gracious to share a lot of that design information with our customers at things such as our ADF, which is an AWR design forum, which is principally in, we have it globally, but you participate in the one that we do at European Microwave Week, which is a nice event, and we thank you for your contribution to that. And then last year we started a series of taking that same content, converting it into technical articles, and also participating in some webinars that you've hosted, which has been wonderful.
I always find that when you sit down to write a paper or a presentation or do the webinar, you actually really learn the subjects in a lot more detail, and you start asking yourself the questions that other people listening to it or you're listening to your presentation would ask, and that makes you go that extra step deeper into it. So I get a lot back from it as well. NIAWR have always been a very good supporter of the RF Microwave Society meetings in the UK, and again, I've found that using those presentations, I've benefited from the ones that some of your colleagues have given at that conference. So it's nice to be able to give back and participate in that way.
It's a win-win, and we appreciate that we have that level of relationship I don't know if people would recognize this, but one thing that happens because we work so closely is you're an early adopter of our new releases.
Yeah.
And so you're on the forefront of seeing some of the new capabilities that we add when a new new release comes out.
Yeah.
So maybe let's pivot. We could talk a little bit about V14. Have you had some opportunity to look at some of the features in that?
I have. I've worked quite closely with a team that have developed or taken on the load pool enhancements. And that's really interesting because now we're seeing sort of getting into the nitty gritty.
Yeah.
So one of the things that I was interested in is, okay, what about the low frequency impedance? We're optimizing the fundamental impedance, but what about the baseband impedance? And so now that information is being contained in the load pool data set as well, whereas before it wasn't stored in the data set.
So what is that doing with that information?
Yeah, that works on the intermodulation performance.
Okay.
So to know how well the intermod is going to work, you have to know what impedance the device is seeing down at the baseband. Okay. So that's what controls good intermodulation.
So you're talking IP3 numbers.
Yeah, that's right.
Does that also impact like ACPR? Or
they're all related.
They're all interrelated.
Yeah. And I mean, I don't use the system simulator very much myself. I'm very much more on the component side.
Right.
But I know all that information can be transferred into the system simulator.
Okay.
And then they can look at the numbers of a whole system going through for ACPR, for example.
Okay. I know that you've done a lot of work with AMSA, who's a partner of ours, and that's an amplifier design aid. Yeah. And maybe you have a better way of describing what AMSA is.
It is a very competent tool in developing matching networks.
Right.
And it's very thorough in the way that it produces its results because it'll give you the complete layout. It'll include monolithic models within the simulation as well. It's very much a complete design package of you enter in the data at the beginning of what you want, of the impedances that you want, and it'll produce the whole layout for you.
Right.
And the integration with MicroApp Office is very good.
Right. Now, you have been introduced to the network synthesis, the impedance matching capability that is going to be in V14.
Right.
Do you have a first impression on it? Or?
Yeah, I mean, I've probably been a bit of a pain in the butt for some of the developers in the beginning because when something first comes out as an idea, all you begin to see is, but how does it do this? How does it do that?
Right.
Why can't I do this?
Yeah.
And they're saying, okay, we'll get to that. But we've got to get the fundamentals right.
Right.
And then also, coming from my area where of the amplifier design, I sometimes got to turn it around and say, how does this work? Because it's different to my approach. And I'm quite fascinated by the number crunching that it has to do. So basically, you list the number of components you want, whether you've got shunt components or series components, and then it tries every single topology and then orders them in the results. And it's sort of almost like a genetic evolution algorithm that it'll try some routes which will be dead ends, but some routes will come out and be a really good solution.
So you think you'd be able to find solutions that you would not have come up with on your own, and it
and I think
unique design.
I think so. But also, usually we define a set of impedances. We say you have to hit those exact impedances. Now, what this might be able to do, and it's still very early days, so I need to look at it, is actually come out at a better solution because the optimum isn't that curve of impedances that I've decided on. It's actually to be a little bit off at this end and a little bit off the other way at another end. And because it's looking at the whole effect, it may well come up with some better solutions. So I look forward to trying that and seeing.
Yeah, it's very interesting. I was watching Chris Bean, who's one of our applications engineers, gave a MicroApp talk at IMS, and was talking about like you're setting goals not to hit an impedance target, but more a performance target. So you're looking for a certain power at a certain gain compression and efficiency or whatever, and then also taking care of harmonic values and whatnot. So, we're looking forward to its release and the feedback from the market. And as you said, we'll dial it in as we get feedback from. I think the interesting thing that it has a strong footprint or signature of PA designers. A lot of input from guys who do this and are influencing its interface and how it operates, and it will reflect that knowledge. You know, it's kind of
Yeah.
automating that. Yeah, so it's good. So I guess wrapping up, will we be able to count on you for more participation in? You're going to play a pretty significant role in our ADF for 2018.
Yeah. They've asked me to chair the conference again this
Great.
year, so I'm looking forward to going to Madrid. I've never been there,
Yeah.
so that'll be interesting.
Excellent. Yeah.
And if we have papers of the quality we had this last year,
Yeah.
which I think are all available on YouTube and through the
From
website.
last year, yep, they're available on awr.tv.
Yeah, and so it should be a very interesting conference again.
Yeah, it will be, and then we'll translate that stuff into more webinars for people who aren't attending European Microwave, and host a couple of webinars with you.
Great.
And make you famous.
Again.
Okay, Dominic, thanks a lot.
Thank you, Dave.
Always a pleasure
Cheers.
talking to you.
Great.